Well, hello, 8th grade students. Mr. Rogers here. I haven't seen you guys for a while, and I hope that this video goes well. I hope you're washing your hands, staying safe, and now wearing masks when you go out in public. Stay 6 feet away, guys. First of all, let's talk about what we're doing. There's lots of confusion about what causes the seasons, and that's why we're doing this whole activity here, or this next week's unit on the seasons. A lot of people don't really know what causes the seasons. They think they know, but they really don't. I hope that these activities will help clarify that so when you get to high school, you will know exactly what causes seasons and not just guess and think you know. I have Tori Cutbirth's paper here, and she did an excellent job. So I'm going to use it as an example of what you guys should have done. These activities were actually real scientific data. They took several schools and they had them record their average day length for that month and chart down, and they entered all this data into the file that you see here, and same with the temperatures around the world. They had the same places take their temperatures and record their average temperature for that month. If you found some missing information, a lot of times that's because that school was on break. So let's go ahead and look down this. I'm going to skip this part here. And first of all, let's just look at the latitude for 70 degrees north here. There is some interesting things here. We noticed that in January, it says none, none, zero. Okay, so day length is 0. The sunset, none. Sunrise, none. What in the world's going on there, Mr. Rogers? Well, what's going on there is they have none. They have no day length, which means in January, November, and December, they have 0 hours of sunlight. You go to bed, it's dark. You get up in the morning, it's dark. You go to work, it's dark. You're at school, it's dark. You go to a basketball game, it's dark. You get tired and you go back to bed, it's dark. And you never see sun for 3 months. But in May, June, and July, you'll notice something quite opposite. In May, there's 24 hours of sunlight. June, 24 hours of sunlight. July, 24 hours of sunlight. That means you go to bed. It's daylight. You get up at about 3:30 a.m. because you get hungry and you get bored. You go to the refrigerator, you look outside, sun's blaring out into your windows, and it is light. So it doesn't matter. It doesn't matter what time of day it is. It's always daytime. How cool would that be? 3 o'clock in the morning, like I'm going to go skateboard, and you go outside, you go skateboard for a while until you get tired, you go back to bed, and you don't need a flashlight because it is daylight outside. That can get pretty confusing. But what would be really interesting though is to watch the sun and how it doesn't really sunset down the mountains. It'll actually just go around the horizon. So imagine you had mountains surrounding your town, and you literally just see the sun just bouncing along, bouncing along, bouncing along, and then just going right around the horizon, and that is your day. It doesn't really get too high, it doesn't get too low. It just stays right there, just bounces around. So that's what it would be like to live in Norway, Alaska, and 70 degrees north in Canada here. Let's go down to, here, latitude 0 degrees. At 0 degrees, we see the day length is 12 hours and 7 minutes in January, and then we get as low as 12 hours and 6 minutes in March, and it goes back up to 12 hours, 7 minutes. Do you really think that they're going to notice a big difference between their summer and their winter as far as day length? Not so much. We notice it here a lot, right? Getting dark at 4:30 in our winter time versus at night at summertime, and we're getting dark at 9:30. Big differences. But if you live right here at 0, that's the equator, you're not going to get much different in amount of daylight. It's going to be pretty much the same all the time. Let's look at our graph. So Tori did this graph again. She did a great job, and that's why we're using her paper today as the example. This is exactly what I wanted. Let's look at this red one here. And the red one says it is 7 degrees north, Norway, Alaska, Canada. And if we look at the complete opposite one, which is this orange line here, That is 7 degrees south. So here's south of the equator, here's north of the equator. Exact opposite amount of sunlight. So if you live at 7 degrees north equator, you have that 24 hours of sunlight period. 7 degrees south, the same time, we're getting 0, none, no sunlight May, June, July. Complete opposite. And that's exactly what happens. North to south, it's complete opposite in amounts of daylight. So interesting times. Now, for comments, I would like you guys to comment below this video someplace and say, what do you think is happening right here? So we have March and we have September. Notice how all the lines come together right there, even on the equator, who always has 12 hours of sunlight. Everybody around the world has 12 hours of sunlight right here and 12 hours of sunlight right here. So what does that mean? I want you to comment on that. Now, here's the big key word here. They have equal amount of sunlight. Use that in your answer. And actually, the term that I'm looking for has the word equal embedded in it. So let's see if you can figure out what that is. But besides that, there's 2 times a year when everybody has the same amount of sunlight. We have the opposite going on everywhere else, except for, of course, the equator, who has the same. So let's look at our temperatures around the world. Now, here's the temperature graph. If we're looking at this graph, it is not symmetrical like the days and nights around the world. It's all over the place. You're probably thinking, Mr. Emery, Mr. Rogers, why in the world did you even have us do this? It doesn't make sense. It's kind of gobbledygook. What can I learn from this? Well, most of these schools are in the north, so we have similar patterns that the arc goes up for almost all of them. But you look down, this one here that's in the south, this is, I believe this is Escuela, Antarctica, yeah. So Escuela, Antarctica, we have July, the temperature is actually its coldest period of time, and December is its warmest period. I think that's what we're really trying to get you to look at, is that even though there's a various amounts of temperature and it's not exactly perfect, so we don't have this perfect symmetrical with, hey, this is 70 degrees or south and 70 degrees north is the complete opposite. We're not getting that exactly. We are getting opposite temperatures, but it is not exact like the days and nights around the world. What I want you to get from this is that the southern latitudes, they have the opposite temperature maxes and minimals as the people in the north. Why don't you think we have perfect equal temperatures when we go north of the equator versus south of the equator at the exact opposite latitudes? Comment too on that. And here's some hints. Have you ever climbed a mountain and warmer on the base of the mountain, but then when you get to the top of the mountain, it was a lot cooler? Or, you know, how close you are to large bodies of water, things like that. So I want you guys to comment on that too. Lots of things affect temperature. I want you guys to come up with those answers for that.